Hello friends, welcome back to my AIML series. Myself Arnab Kundu. You are watching my channel Technical Arcoin. In today's video, we will learn hyperparameter tuning in machine learning, and also we will see how to use GridSearchCV to automatically find the best parameters for a model and implement it step by step. Okay, so let's get started. Hello everyone, today we will discuss hyperparameter tuning in machine learning using GridSearchCV. Okay, hyperparameter tuning helps us improve model performance by selecting the best parameters automatically. Okay, so at first we should know what is hyperparameter tuning. Hyperparameter tuning is the process of finding the best configuration of parameters that control the learning process of a machine learning model. Okay, key idea: hyperparameters are set before training and influence how the model learns from data. So examples like that, models like decision tree, the hyperparameter like max underscore depth; random forest, hyperparameter is n underscore estimators; SVM, support vector machine, hyperparameters c and gamma; KNN, hyperparameters is n underscore neighbors, right? Now we talk about parameters versus hyperparameters. Model parameters, actually the parameters are learned automatically during training. Examples: linear regression coefficients, neural network weights. Hyperparameter means hyperparameters are set by the user before training. Example: learning rate, tree depth, number of neighbors in KNN. So key difference is that for parameters, when determined during training, hyperparameters when determined before training, right? Now I talk about the workflow of hyperparameter tuning. Okay, steps like that: select a machine learning model, define hyperparameters to tune, use GridSearchCV or randomized search-CV, and today's video is concerned we are using GridSearchCV. Okay, perform cross validation and select the best parameters. So what will be the output? The model is trained using the best hyperparameter configuration, improving prediction performance, right? So now let's move to the Google Colab and implement hyperparameter tuning in machine learning step by step. Okay, so now I am just within the Google Colab workspace and the code is already written. The code for hyperparameter tuning using GridSearchCV, and dataset is used here: breast cancer Wisconsin dataset. Actually the breast cancer Wisconsin dataset is a widely used dataset in machine learning for binary classifications task. Total number of sample 569, input features are 30, and target class 2 malignant and benign. Okay, and the first step we already know: import the libraries. So first we import the required libraries. We use the NumPy for the mathematical computations like array, pandas for the data analysis, for data handling and numerical operations. From scikit-learn we import the breast cancer dataset, the train test split, and the GridSearchCV for hyperparameter tuning, standard scaler for feature scaling, and support vector classifier as our model, and finally accuracy score to evaluate model performance. So for these tasks we need this module, and which I just import within my program. Okay, and the step 2 is that load the dataset. So next we load the breast cancer dataset, which is actually a breast cancer Wisconsin dataset. The dataset contains several medical measurements of cell nuclei. We store the input features in capital X and the target levels in Y. There are two classes of target level, one is the malignant and there is a benign. but the model will learn to classify tumors as benign or malignant. So we just load the dataset and then we just separate the input features and the target class. Number 3 step is that train test split. So here we split the dataset into training and the testing set using train underscore test underscore split. Here 80% of the data is used for training the model and the 20% is used for the testing its performance. The random underscore state parameter ensures that the split is reproducible every time we run the code. So that's why we just use here x underscore train, x underscore test, y underscore train, y underscore train, and use this function train underscore test underscore split. Just given test underscore size, just given 0.2 means 80% for training and 20% for testing. Okay. Now the step 4 is feature scaling. So next we perform the feature scaling using standard scaler. First we feed the scaler on the training data and transform it. Then we use the same scaler to transform the test data, ensuring that both datasets are on the same scale. So use here standard scaler, then use method fit underscore transform and transform. These two methods we are using here. Okay. After the step 5 is define the model. So here we are using the SVC, means support vector classifier. Next we define our machine learning model. Here we use the support vector classifier or SVC, which is a popular algorithm for classification problems because the target class is two, one is malignant, other is a benign. The next, the step 6 is that define hyperparameters, which actually the main motif of our code. We define the hyperparameters grid for our model. This grid contains different values for the parameter C, kernel and gamma, which GridSearchCV will test to find the best combinations. So use here C, kernel and the gamma, right? C, gamma and kernel are the hyperparameters of the SVM, means the SVC model. GridSearchCV finds the best values for them, right? And then the step 7 is that GridSearchCV. So next we apply the GridSearchCV for hyperparameter tuning, and GridSearchCV will train the model using different combinations of the hyperparameters defined in our parameter grid. So we use here 5-fold cross validations to evaluate each combinations, and the performance is measured using accuracy. And finally we feed the GridSearchCV object on the training data. So there we are using this GridSearchCV and use some parameters like estimator equal to model, param underscore grid equal to param underscore grid, and CV equal to 5, and scoring equal to accuracy. Okay, and then we use the fit method here and send as an argument x underscore train comma y underscore train. Okay. Now the step 8, best parameters. After training the GridSearchCV method, we print the best hyperparameters found during the search, and these are the parameter values that produced the highest performance during cross validation. Okay. We also print the best accuracy score obtained during the tuning process. Okay. So that's why we just print grid underscore search dot best underscore params underscore, right? And also we print the best cross validation score. So just print grid underscore search dot best underscore score underscore. Okay. Now the step 9 is the last step for best model evaluation. Here we retrieve the best model found by GridSearchCV using the best underscore estimator underscore attribute, and then we use the optimized model to make predictions on the test dataset. Finally we calculate the test accuracy to evaluate how well the tuned model performs on unseen data. So in that case we just use here best underscore model dot predict and then accuracy underscore score, and after we just print the test accuracy with the best parameters and print the accuracy value. So we just run this code, just press this button. So it will take some time to generate the result. So just see the result is given. Best hyperparameter C is 1, gamma is scale, and kernel is RBF. Okay, and the best accuracy is given 0.9758241. Okay, and test accuracy with the best parameter, so near about similar 0.982456140, like that. Okay, so here actually C equal to 1, gamma is the scale, and the kernel is RBF, means the C1 means the model strongly tries to classify the training data correctly while still maintaining a margin. Okay, and gamma equal to scale means the gamma value is automatically calculated based on the number of features and the variance of the data. and kernel equal to RBF means the model is using a non-linear decision boundaries to separate the classes. Okay, so here C controls the regularization strength, the RBF kernel allows non-linear decision boundaries, and gamma determines how much influence each data point has on the model. Okay, I hope you have understood how hyperparameter tuning is done within the machine learning, and here I am using GridSearchCV, this method. Okay, if you have some doubts for today's video discussion, just write in the comment section. I will try to solve this problem. If you have not subscribed my channel till now, just subscribe it, because more AIML videos will come very soon. So today up to this. Thank you and bye bye.